Hi there, I'm Michael Cohn from Advanced Tubular Technologies. In today's video, I'm going to show you how to find the position of each of these components as if they were drilled holes in the tube, because they can be treated as drilled holes. And you can see these are components that are brazed onto this tube assembly, but we need to know where these are along the tube and also what their angular orientation is relative to each other and to all of the adjacent bends. So here's what we're going to do. I'm going to go to collected features after having imported this model, and I'm going to first of all collect all of the straights in order like this. I'm left clicking with the mouse. I'm going to right click with the mouse and rebuild the parametrics. That's simple. Now you can see it's working its way through the tube, and it's created the XYZ coordinates right here, the center line, and the bender data down here. Now let's do some work on these components. What I'd like to do first is I'm going to scroll down to where you can find the cylinder drill surface, because we're going to create a drill bit boss for each one of these components. So this is straight 2. It's important that we get the straight right, because we want to let VTube know which straight it's on. You can select either the inside or the outside, it doesn't matter, because it's going to always measure to the center no matter what. So I'm going to right click here, zoom out, and let me just go ahead and orbit around. So you can see this point 4 right here. This is 4 to 5, so that's straight 4. Let's go straight 4. I left clicked and then I right clicked. Now we're on straight 5. And we're finished. So I'm going to go ahead, and we don't need to rebuild the parametric too, because it's already been rebuilt. But what we do need to do is rebuild all the drill bit bosses like this. So the purple drill bit bosses are shown here, and you can see them in the constructed features over here in this menu. Now what I'd like to do is go to reports, and we're going to run the hole clocking report. And now you can see all kinds of data pertaining to the holes relative to bend planes and to the end. So right here we've got a 90-degree orientation or rotation from the first hole to the first bend plane. And next you can see that we have the distances to each of the centers of the holes from the end of the tube. And the report even shows the clocking of all of the holes relative to the first hole, which can come in handy for alignment. VTube also responds to tube elongation percentage changes, which means it's going to change the distance of the hole if the tube elongation percentage is set to something that's other than 0. So in this case, it's set to 12%. And then we're going to turn on the AutoCalc with elongation compensation and go back into that same report. And you're going to see that the first distance, instead of being 19.466, is now 19.183 inches. So it actually has moved slightly in space relative to the elongation in the first bend, and all of the distances respond this way. So that's how easy it is to clock the position of drilled holes and or components that are like holes inside VTube STEP. If you have any questions about what you've seen in this video, please feel free to reach out to me or my team at support@advancedtubular.com. Thanks for taking the time to watch this video. Have a great day.